Hello everyone, this is Jamie here. Welcome to another session of Vista Export Services. In this session, I'll be taking you through some of the amazing new Camera Match AutoSetup features now available to download for free if you already have the individual or a studio license using 3ds Max or Blender. These new features are also available for SketchUp, except for the GeoBuild and the Google 3D tiles. Having said that, GeoBuild and Google 3D tile features will be available in the next release of SketchUp. Also, I'm currently working on a Cinema 4D version of this script. So without further ado, let's start by dragging and dropping the script into the 3D scene. Users can also customize the script as a button, so it automatically loads up when you start the program. Also, if you use V-Ray, Corona, Arnold or any other rendering engine, simply load it before running the script. In my case, my default rendering engine automatically loads up when I start the program. Let's start by clicking this button to browse for image. Choose the image you wish to camera match automatically and click on this button here to auto detect VP and apply to camera. Click yes to apply the camera parameters, OK to accept the done dialog, and voila! The correct camera lenses were automatically created and rotated. The background image was automatically inserted with a safe frame, with the correct render output size and the vanishing points. Also, there was an automatic VP verified box created in the 3D scene to help verify the camera's alignment. Let's start by moving the VP verified box to check its alignment with the background image. In a camera viewport, let's click to select the camera from the list, open the modify panel, double click to enable each target, and select the camera target from the list. Let's maximize the camera viewport to look closely and begin moving the camera target with the move tool. You can see the grey horizontal camera horizon line shifting as we move the camera target. Let's use the camera 2D pan zoom mode to zoom in closely to see it properly here. Let's zoom back out and move the camera target vertically to align closely with the yellow horizontal line from the VP detection. Sometimes the yellow line is not perfectly horizontal depending on the photo. In such cases, the camera horizontal line simply needs to sit on the highest point of the yellow horizontal line, or sit in the middle between the highest and the lowest point of the yellow horizontal VP line. Now that the camera is perfectly aligned, let's select and move the VP verified box to align with one of the building structures. The sole purpose of the VP verified box is to help verify the accuracy of the camera alignment. You should never rotate the VP verified box unless it's 100% obvious from the photo, or when you have the drawing outline or its footprint in a 3D scene to refer to. Let's start scaling the VP verified box using real values to fit the structure. Always use the real values to scale an object, as they will prove crucial in a camera matching accuracy. The camera is 100% matched now. In this updated script, we have a new background mode section with toggles such as clean photo to remove vanishing points in a photo by clicking on it, the VP overlay plus horizon to place the VP lines back on, clean photo again, and the hide toggle to hide the background photo altogether. The following step is to open a fresh new 3ds Max scene with the system unit set up properly and open a new script called GeoBuild. The script is also free to download if you already have the freelance individual license. Let's start by typing in the address or copying and pasting it in a section here. I know the precise address because I've worked on this project, so I'm simply going to paste it here and press enter on my keyboard. Users can also click this button to search instead. As you can see here, the address was immediately found. Sometimes it doesn't find your address because of certain commas or and symbols. It's not the script problem. It's directly connected to how the OpenStreetMap website conducts its searches. Sometimes you just need to edit the address. Following that, let's scroll down and click on a button to apply map space. Let's scroll down to this OpenStreetMap section and click on this button to go to the website. In the OpenStreetMap website, let's paste the same address again and click to search. The following step is to click to export here and click this button to manually select a different area. Let's manually select the area we want to bring into 3ds Max. This is our building here. Our camera is sort of sitting here, looking across there. Next, simply click to export and click to save as here. I often name the file according to the address without commas or special characters. Back to our 3D scene, let's click on the OSM file toggle here and load the previously saved OSM file. This dialog immediately asks users if you want to also fetch the matching terrain height map, the aerial satellite photo, etc. We're going to click no because we later intend to bring in the Google Photorealistic 3D tiles, which are 100% accurate. OSM files are extremely good to retrieve outlines, height, structure names, etc. However, there's a 5 to 10 meters offset and they are not 100% accurate like Google. Let's scroll down and click to build map, and it's done. We have our OSM file, blocks, names, outline, height, structures, etc. Let's group them and name it. The following step is to bring in the Google Photorealistic tiles. Let's scroll back out and enable the Google Photorealistic 3D tiles option here. there are two main parameters to concentrate on: the max screen space error and the max tile depth. With the max screen space error, the value of 0 is the maximum quality, which takes some time to compute. Let's type in the value of 10 instead. If you hover over its spinner, you can actually read its functionality. Let's change the value to 8. In the max tile depth value, it works in the opposite way. Higher values yield better results and take longer to compute. For the purpose of this exercise, let's type in the value of 100 for the sake of time. If you hover over, the maximum value is 1000, which will take considerably longer to compute. With these two current values, we should be able to retrieve a decent 3D model with textures to work with. To fetch the Google Photorealistic 3D tiles, let's scroll down and click to build map. And voila, it's in the scene like magic. It took around 3 minutes to fetch. In order to access the Google Photorealistic 3D tiles for free, you need to register and get a unique API number from the Google Cloud Services. There's a free PDF available to download in the link below, taking users through the process of quickly registering and getting the API within minutes. Next, let's group and name the Google 3D tiles. Personally, I prefer the Google 3D tiles to sit below the OSM model because of what we will be doing next. However, feel free to do the opposite if you prefer. I don't suppose it matters, since most architects and developers will provide you with the finished floor level values to accurately place your proposed building in. As mentioned earlier, at first glance the OSM group seems to be aligning perfectly with the Google Photorealistic 3D tiles. However, there's a 5 to 10 meters offset vertically and horizontally, bear in mind at all times. Let's hide the OSM file for now. This is our building here, and our camera should be sitting here looking across there. Let's hide the Google 3D model for now and unhide the OSM 3D model. Let's open the group, select our building and change its color. Next, open the Camera Match script in the scene. While the red building is selected, under the Scene Scale Calculator section, click to read height from selected object. As you can see, it's 25.6 meters tall. Let's go back to our camera matching scene. Under the Scene Scale Calculator section, in real wall height, type in the 25.6 meters. While the VP verified box is still selected, click to read height from selected object. As you can see, the current height of the VP verified box is 13.5 meters. To match this scene scale with the real world, simply click to calculate and apply system unit scale and click OK to close the dialog. As you can see, the scene is now to scale and the VP verified box is now 25.6 meters. When a scene is calculated to match the real world scale, the system unit setup is automatically changed to achieve this calculation. As you can see here, the following step is to X-reference the Google 3D model into this camera matching scene. Let's first group our camera and VP verifier box as one. Adjust its pivot point to rotate from the specific point. Name the group accordingly. Back in our Google models scene, let's close the OSM group and unhide the Google 3D model. Hide the OSM group. Let's save the scene. Back to the camera matching scene. Let's go to File, Reference, and choose the X-reference scene. Pick the Google 3D scene, and voila! It came through. The following step is to rotate our match camera group towards the building here. Let's isolate the camera group. As you can see here, the camera group and the background image are intrinsically connected no matter where the camera is moved or rotated towards. Let's exit the isolation. Let's align our match camera group with the existing building by rotating and moving the group accordingly. As you can see, it's quite evident the original camera shot was taken on this spot. Everything seems to be aligning perfectly from every angle. Because we will be exporting the camera data transplant to the main Google 3D scene, let's remove the X-reference file to prevent X-reference file loop. Let's save the 3D scene and click to export camera data for transplant. Name and save the JSON file. This JSON file also retains the scene parameters such as the background image, render output size, etc. The original camera match scene should always be kept separate from the main scene for reference purposes, especially when the system unit setup values have been changed. Exporting the camera data transplant will keep the camera and the scene accuracy at 100%, whereas if you were to simply merge this camera group into our 3D scene, there would have been a camera and VP verifier box offset because the system unit setup values had been changed. Let's go back to our main Google 3D scene and click to import camera data from Transplant. Let's choose our previously saved file and click yes. As you can see, the JSON camera data file brought in the camera, VP verifier box, the background image, and the render output size parameters perfectly match into this new scene. Now we can start working from here because the system unit setup has not been fiddled with. As mentioned earlier, if you were to compare between the OSM map and the Google 3D file's accuracy, you can clearly see the OSM offset by a few meters. So whenever possible, always use the Google Photorealistic 3D tiles as a guide because it's a millimeter accurate. Let's reset set the scene now and introduce an amazing new feature also free to update with your current freelance individual license and the studio license. It's called Crop Photo Tool. Let's browse for image and bring in a photo that will truly benefit from this Crop Photo Tool. Let's click the Auto Detect VP and apply to camera. The camera VP verifier box and the background image have been automatically created. As previously done, let's start by selecting and moving the VP verifier box to see how well the camera match the shot is. As previously done, let's first select the camera, open the modifier panel and double click on the targeted function to enable the camera target. Select the camera target from the list and begin moving it down until the grey camera horizon aligns with the yellow horizon VP line seen here. Next, let's select the VP verifier box. Begin changing its dimension values and moving it in the scene accordingly to fit with the background photo. Due to the fact that this photo was originally cropped to be framed properly for publication, we are getting this camera distortion seen here, which will be near impossible to camera match in a traditional way. For such instances, we now have the Crop Photo Tool. As mentioned earlier, this tool is available for free for those who already have the freelance individual licenses and the studio. In a Crop Photo Tool section, click to pick horizon on photo. The horizon Y point we'll pick in this dialog needs to be more or less where the yellow horizontal line seen in the viewport is, just above the plant. After picking the horizon line here, you can also use the down by 1 button to move down, or down by 10 move down even faster, or up by 10 move up faster. Once happy with your horizon position, simply click to use this Y value to accept it. Now that's done, let's click to generate extended image and auto detect VP. Let's accept the new camera parameters and that's it. Now let's select the camera target again and move it up until the grey camera horizon aligns with the yellow horizontal vanishing point line. Now let's select the VP verifier box again and adjust its position accordingly as previously done. We can also select the camera target again and move it in the X direction to help align it perfectly. To pan the camera, first exit the 2D pan zoom mode. Hold on the mouse scroll wheel and begin moving it to pan the camera. While the camera target is still selected, move it in the X direction and pan it accordingly. Now it's matched 100%. As you could see, camera matching the original crop photo would have been near impossible without this new Crop Photo Tool because the original photo had been doctored. Let's duplicate the VP verifier box and align it with the house behind to see how well it aligns. Everything seems to be matching 100%. As mentioned earlier, all these features are free to download if you already have the freelance individual license or the studio license. For drone photos discussed in my previous video, or for images with landscape without buildings or structures, you need the studio license instead. This is a studio version of the Camera Match script. If per chance this photo only had trees and sky without the building structures, the standard Camera Match script for freelance individual users wouldn't have been able to match it properly. With the studio version of this script, users can simply enable the rural landscape mode seen here and click to auto detect VP and apply camera to match the shot with accuracy. Also, with the studio version, users have everything that's already included with the standard Camera Match script, in addition to drone site builder script for drone photos, the GeoBuild script, up to 5 user seats, infinite free updates, the rural landscape mode, post level horizon, and much more. I really hope you found this video and the script useful, and I hope to see you on my next one.